Welcome to Shippers Log. I'm Dimitri from Envio, and I'm really eager to show you our new feature block handlers, which was released in the version 2.29. So, block handlers, you can do literally everything with them, like traces indexing. This sounds cool, and we'll come back to this later because this feature allows quite a lot of creative use cases which weren't possible before but possible now, but also it's just like a general indexer feature which is useful for some normal use cases. And let's begin looking at them. So I have the documentation page open. You can find the documentation for this new block handlers feature under the guide section. And how to start is you don't need to add anything into a config file or schema GraphQL or like run code gen. You just import onBlock function from the generated module and just register it in your handlers file. This function accepts two arguments. The first argument is an argument with options, where name and chain are required. Name is useful for debugging, profiling, like some metrics, performance, also logging. So every log which will be fired from a block handler will include this name. So if you read some logic, it will be quite nice to find where the flow comes from. Also chain is also needed because this block handler will run on every new block which happens on this chain, and it will start from a block configured in the config. So it will reuse the chain start block by default. It will also reuse the chain end block by default, and it will fire this function on every block by default. Other options, you can configure the interval. So if you don't want this to be fired on every block, you can fire it on every 10th block or every like 20, so like every 100th, any 1 millionth block or whatever. Also, you can change the start block or end block if you want to have something different from the range configured for the whole chain. And this allows quite some interesting things you can do with this. But let's take a look first at the handler function. And handler function is quite simpler. It uses context, the same context object you have for event handlers. And currently the block handlers support only preload optimization mode. So if you want to use them, it's required to enable preload optimization. So the handler function will run twice. And if you want to disable it, you need to write if context that his preload return, and below this line, the rest of the code will run once. Read more about this behavior in our preload optimization guide. It's in the advanced section. This is really nice. And yeah, and also the block object, currently only number and chain ID provided. Add more fields, you'll add them in the future, but you can use effect API and get them from RPC by just calling get block by number, and have this effect API. It will be quite fast. So let's skip the multi-chain part and take a look at the time interval. And as I said, why interval is quite an interesting thing is because it also allows you to have some time-wise logic. For example, you want to recalculate prices every hour or every day or something like this. And now you can do this using block handlers. And how to convert time into block interval, you need to know, it's not exactly 100% precise, but if you know a usual block time for a chain, for example, 12 seconds for mainnet, and you know that, for example, I want to run this on every hour, you just divide an hour with the number of seconds a block takes, and it will be the block interval will be 300, which will mean that for a mainnet, it will fire every 60 minutes. This is nice. And yeah, also, let's go back to multichain And multichain is also possible, not natively with this API, but I saw that you can use JavaScript, like they got invented JavaScript, so why not to use this? So to use this block handler for multi-chain, for example, you want to run a separate function for every chain, just create an array of configurations and iterate over it and define the onBlock. You can do this dynamically. And yeah, it's just works perfectly fine. So this is multi-chain also supported. And a few creative use cases by having this onBlock API to be dynamic and not in the config, that you can also have multiple block handlers for a single chain. And you can, for example, have different intervals for a same handler. And for example, for historical sync, you can define a block handler with an interval of 1000, finish it right before the real-time mode starts, and then starting from real-time block, run the block handler on every block. So for example, you can quickly finish the historical sync, like lazily calculating some data you need for your indexer, and then in real time indexing, you'll do calculation every block. So every new block, your indexer will have an up-to-date data, so it's immediately available for querying. This is nice. Like also it uses multi-chain and this hacky thing. Not a hacky, it's like it's designed this way. It's just, I would call it creative. And another interesting thing, you can already see it at the end of my screen, is that this feature allows you to have a preset handler, and you can use this by setting start block and end block to the same value where your chain start block is. And like this is the way how you can disable preload optimization. You don't need preload optimization for preset because it runs only once anyways. And this way you can load any data from wherever you want and write it to the indexer database. And yeah, just amazing. I call it amazing. Yeah, also there are a few limitations. The one I mentioned, the preload optimization that's required. Currently, you don't support ordered multi-chain mode. It only works for an ordered multi-chain mode or for single chain indexers. And no support for fuel. But all EVM chains, either with HyperSync or RPC, are supported. Also, our test framework still don't support onBlock handlers. And block object contains only number, but as I said before, you can use fheaded API to get the rest of the data. This is cool. Like, and all of these cases are quite interesting and allow you to do a lot using these block handlers. And I'm telling you that this implementation you have is the fastest block handler you can imagine. I would say it's just the fastest. And as I mentioned in the beginning of the video, I'm gonna show you the indexer which uses most of these features, and it uses them together with a HyperSync client directly from the indexer to make indexing on traces. This is super cool, and let's take a look at this. Okay, I'm in IDE, and before I start looking at the code, I'll tell you what the indexer does. So this indexer walks through the whole mainnet chain and finds all the contract deployments. And it stores the address of the contract deployed on the chain and also the block when it was deployed. So this is quite simple, but it allows the things which weren't possible before. For example, you can quite easily get the number of all contracts deployed on mainnet, or look up the log where it was deployed, for example, to use for indexing. And this is not really useful for HyperSync because HyperSync quite cleverly skips all the blocks where there are no events. But for example, if you use RPC for indexing, it might be quite useful because otherwise you don't know where to start. And yeah, let's take a look at the code because I think the code it should give you some inspiration how you can use block handlers in a creative way. So this is why I created this Unix in the first place. Okay, it has two block handlers. One is historical, another one real time. It's reuses the same logic. We'll take a look at this a little bit later. And historical starts from the beginning and it goes to the save log. Currently, the only way to use save log is just hard-coded. I loaded it to the value which was the latest 2 days ago. But I think it's still an amazing way to optimize the historical sync. And why I say optimize, because for historical sync, we go with ranges of 200 blocks. Yes, realize that this is the most optimal for this use case. It might be even more. And then starting from real time, we switch to every single block. So we have latest data, as I mentioned before. And yeah, as there are also some limitations, like for example, start block and end block. We define end block, and then we also have a start block for real time, where we some intervals, there are some conferences, and in the handler, what we do, we call an effect. And as I said before, block handlers use preload optimization, and having an effect call, it's like super fast. So yeah, and I'm going to run it soon, so see the performance. And in this effect, we get created contracts. Actually, doesn't really matter the way you get this, the implementation, but we'll take a look at the implementation later as well. And we get the contracts from this block range from block and to block, and then we just set it to the database. This database write also used our internal matching system, so it will turn it into a single SQL query, and it will also use insert and nest, which is not much, but like something like twice faster than just insert values. So this is nice, and like some small things which you usually don't know when using HyperIndex, but we thought a lot of optimizations which make it much faster than you could think of. Okay, and then effect API. Let's take a look at the implementation here. We define an effect, name, input and output. This is a small hack to optimize the input size for caching, but I don't use caching here, but it's just nice for lookup as well. It will be mentioned at some point in the separate effect API guide. And yeah, and the logic here itself, what we do, we actually initialize a HyperSync client, a separate HyperSync client, which supports traces here. So we use HyperSync to get the indexer block progress, and also use HyperSync client inside of the indexer handlers, which is quite a creative approach. And here we create a query where we request traces with kind create, and also we request all transactions with contract address and block number. And what it means that if you get a trace and it has address and block number, this means that it's contract deployment. If you get a transaction where contract address is not null, it also means that it's a contract deployment. So we push it to the result and return it from our effect. So this is quite nice. And let's open the terminal and build the example before, and let's start and see how it runs. So we have some sort of live demo in this video. Okay. My bad, I should have run it like this. The thing is that I had to set max batch size so we don't run this 5,000 effects at the same time. Okay, and you can see that now it progresses smoothly. And let's open the console and see how it goes. So it's already in 20 seconds processed a million of logs, and call was quite fast. So when I deployed it on House of Service, it finished in something like 20 minutes, and it written more than 80 millions of contracts. And let's open the playground and see how it looks like. So we have a contract aggregate entity here, and also let's take a look at the contract itself. I'll add a limit here just in case, because I know that in playground there is no limit by default. And we can see that we already have 200 addresses added to the database. And here how the entities look like. So there is a contract address, and here's the block number where it was deployed. Amazing. So block headers is an amazing feature, and definitely go to our HyperIndex repository, leave us a star, and follow up this channel, and also follow us on Discord to see more amazing releases. Cheers.